Hello, I'm Banka, and today I'm gonna show you how to apply optimization in RTS games. Let's face it, most RTS games are based on optimization, at least in the power battle, where you have to strategize, and for that you need to know what is the biggest amount of units you could use, and at the same time have some units in reserve for the end and still get the victory. For the purpose of this video, we're going to focus mostly on the way a regiment unit could be optimized for, let's say, movement or attack. Let's suppose we want to optimize the regiment so that it is able to resist the shock from cavalry that could be attacking from the enemy. We go ahead first and draw our rectangle, since the formation of regiments back in the 1700s were rectangular, and I went ahead and put 2 W's and 2 L and what you see in the image, because that will remind me that I have 2 width, one at the top, one at the bottom, and 2 length, one at the right and one at the left. That means I will use this layer for the perimeter. This also means that the target of our optimization will be to minimize the width of the regiment. And I went ahead, and since I was using line infantry regiment for this example, which has 128 soldiers, I decided to use as units of measurement soldiers, and therefore I could get 120 for the area. And that also means that for the perimeter I got 44. So next I set up the question based on the area, and this means that area is equal to length times width, which means 120 is equal to length times width, and I went ahead and divided by W, by width, because we want to optimize the width, not the length. And so we get 120 divided by W is equals L, and I left it at that and went back to the and made another equation that we need for the optimization, since in optimizations we need at least 2 equations. And when I wrote 2W plus 2L is equals to 44, and this when these numbers come in play, and that means I plug in the W, the what I got from the other equation, and I was where I had length is equals to 120 divided by W. I put that 120 divided by W for each L, and I got 120 divided by W 2 times, plus 2 times width is equals to 44, which gives me 240 divided by W plus 2W is equals 44. And since I didn't want any variables in the denominator, I multiplied by W in the left of the equal sign, and so I ended up with 240 plus 2W squared is equal to 44. I took the first derivative of this in my mind because we have in such a simple form that we can say the first derivative is 4W equals 0, and the second derivative is 4, which has a positive sign, and that means that it's concave up, and therefore the point that we get when we solve the equation in its original form before we took the derivative, we'll end up with minimum, which is what we want. And so we solve the 240 plus 2W squared equals 44. We solve for W, and we get 2W squared is equals to negative 196 when I subtracted 44 by 240, and then we get W squared is equals to negative 98. And the next I moved the negative sign to the left of the equal sign because that way I wouldn't get um, imaginative numbers from when I take the square root of 98. And so again, negative w is equals plus or minus the square root of 98, which is 9.8, and therefore I would choose the negative 9.8. So with the negative before the w, I get positive 9.8. And I went ahead and rounded that 9.8 to 10 because we're dealing with humans for the area, so that means we cannot really cut a piece of one of our soldiers and put in one place and have the other piece in another place. So we went ahead and I rounded to 10, and so 120 divided by 10 is equals to 12, which is the length. So that means our length will be 12 and our width will be 10. And we actually minimize the width because the original width was being 40, and we expanded our length, which would have been 3, now we have 12. And so this is important for the next part. So here we are and testing out our new formation optimized for against cavalry, and I'm getting close to the enemy. They're British, and if we did the calculations well, we might actually beat the British. And here we go. If you see, the formation fared pretty well. There were more surviving units than I had expected, and eventually I won in this battle. Here we go. This is the end screen. That means they actually survived. So this is it. I hope like you learn how to optimize and apply these optimizations into gaming. It's whatever. I guess the Americans only needed to know calculus back in the days in order to win for sure. They should have gone to school, I guess. Oh well, they went to school. Whatever. See you later. And there is no cake. The cake is alive. Still alive.